Hello, in this session we will see about parity codes. Parity codes are also known as error detecting codes. That means they will detect an error in the received code. And these codes are only used for identifying or detecting the error, and they are not used for correcting that error. Using parity codes, we cannot correct the error, we can only detect the error. And the main drawback of parity code is only a single bit error can be identified or detected. For example, if there is a 4-bit code which is transmitted, a 4-bit code which is transmitted, and in the received side we received the 4-bit code like this. In this case, there is no error. What code we have transmitted have received here. In this case, there is no problem. But if the received code is like 1011, now there is an error, because in the transmitted code, the last bit, the rightmost bit is 0, but in the received section it is 1. So this is known as a single bit error. Out of 4 bit transmitted, only 1 bit is changed, or we can see the error happened in only 1 bit. So this parity codes is used to identify or detect these type of errors. Only a single bit error can be identified using parity codes. Suppose if there are error in 2 bits, for example, if the first bit and last bit are different, that means first bit is 0 and last bit is 1. In this case, you can see the first bit is changed from 1 to 0 and the last bit is changed from 0 to 1. That means in the received code, 2 bits are changed or 2 bits are error. In this case, we cannot use parity codes to find error. So parity codes are used to detect error only if the received code have a single bit error. We will see the different forms of parity methods. There are two types of parity named even parity and odd parity. So these are the two types of parity schemes available. First, we will see the even parity. Suppose our code is 4 bit. Suppose our code which is need to be transmitted is 4 bit and it is 0101. This is code we want to transmit 0101. Before transmitting, if we are using parity method, we will add one more bit, that is known as the parity bit. We will add one more bit known as the parity bit and append to this code value. We can append this parity bit either at the starting or at the end. Either at the starting or at the end. I am going to append the parity bit at the starting. So this parity bit can be either 0 or 1. Parity bit can be either 0 or 1. In even parity mechanism, we have to check the whole code word. In the whole code which is going to be transmitted, there should be even number of ones. Even number of ones. There should be even number of ones. So if I am going to add a parity bit as 1 here, then in this total code we have how many ones we have? This is 1, 2 and 3. 3 ones are there, but 3 is not an even number. So we need even number of ones. So we have to add parity bit as 0. we have to add parity bit as 0. Now the number of ones in this code is 2. There are only 2 1 available in this code. So 2 is a even number. We have even number of ones in this code. This is even parity. So whatever 4-bit code is given, we can easily convert it to even parity. I will show another example. 1110. This is the 4-bit code. So what will be the parity? We need total, after adding parity, we need total even number of ones. Now here only 3 1, that is an odd number. So we have to add 1 as the parity bit. Now we have a total of 4 ones, which is an even number. So total number of ones after adding parity should be even in even parity mechanism. Similarly, in odd parity, we have 4-bit code and a parity bit. Suppose the 4-bit code is 0110. Now the number of ones is 2 here, that is even number. So to make it as an odd parity, we have to add 1 to the parity bit. Now the total number of ones in this 5-bit code is 3. There are 3 ones, which is an odd number. So this is meant by odd parity. I will write one more example, 0111. Now the total number of ones is 3. Already there is odd number of ones. So we have to add parity bit 0. So now the total number of 1 in this code is 3. If we add here as 1, then the total number of 1 will become 4, which is an even parity. So this is the case of odd parity and this is the case of even parity. We will try a small problem or an example. Suppose a system, that means transmitter and a receiver, is using even parity. Suppose the transmitter and receiver is using even parity and a receiver received an 8-bit code 10110111. This is the code received by the receiver and they are using, the transmitter and receiver are using 8-bit and they are using even parity. Now we have to find whether the received code word have error or not. We have to find the received code word have error or not. Since the transmitter and receiver are using even parity, we have to count the total number of ones. Total number of ones, that is 1, 2, 3, 4, 5, 6. Total number of 1 is 6. 6 is a even number. 6 is an even number. So there is no error. If the last bit is 0, then we have a total number of ones is 5. Now 5 is an odd number and we were using even parity, so this received code word will be having error. So this is how we check whether the received code word have error or not. But the problem with the parity method is that we can detect only a single bit error. If more than one bit is changed or if there is an error in more than one bit, then we cannot detect error in parity method, as we have discussed in the starting of the session. This is all about odd parity and even parity.